Hi, my name is Hannah, and this is my video to be a Chem ULA for this upcoming fall. Some things about me: I'm a first year at UNC. I took Gen Chem 1 in this past fall. I'm in 102 right now. And another interesting thing about me, I'm studying abroad this summer in Australia, and I'll be taking Intro to Organic Chemistry while I'm there. Moving on to why I want to be a Chem ULA. I think the main thing for me is I struggled a lot when I first got here, especially with Chem 101 and adjusting to the learning environment in the giant lecture hall, not really having one-on-one access with your professor. But I felt like the biggest thing that helped me adjust was the ULAs and the fact that we had access to office hours as well. And I also felt like just having the ULAs that as a resource, and someone who has recently been in your shoes before and understands like what it's like previously, I feel like that was a big help. And it's a lot less intimidating to ask them for help than say your professor, especially in a giant lecture hall, and just having them there as a quick resource to help clarify any gaps of knowledge or misunderstandings was really helpful. But yeah, and I think for me, I just want to be a part of that process as well and making an impact on other first years that come in with absolutely no background knowledge in chem at all, which was me. I also want to be that person as well. And I don't know, I just have a passion for helping others and teaching others skills that I once struggled in, and then like teaching them how to do it for themselves. I find it very fulfilling. And I also just think the aspect of learning is really interesting, and understanding different learning styles, etc. With that being said, one of the main strategies for students to help them study and learn the content better, I think the main thing is understanding exam type questions, and firstly understanding what the problem is asking for, actually being able to read and analyze the problem and understand what it's asking for, what information do I have, and how do I relate the information given to the information that I don't have. What equations relate the information I have and the information that I don't have. What principles or concepts relate these two things. I think that's the biggest thing that a lot of people overlook, is that the answer to the question is in the information given, in the context provided. And I think by emphasizing this for students who aren't really familiar with the style of questions and the wording of the Gen Chem exam time questions, I feel like this will be really helpful. At least that's how it is for me, because now every time I encounter a problem, I immediately think about, okay, what is the problem asking me? What do I have? And how can I relate these two things together? What equations or ideas relate these two? And how can I use that to get what I need? But yeah.
Okay, so this is the problem I chose to go over. It's one of the Chem 101 problems from one of the practice exams they provided last fall, and it is a dimensional analysis problem. And it says that the U.S. National Academies of Sciences, Engineering, and Medicine determined that an adequate daily water intake for the average college student is 13.5 cups per day. According to this recommendation, how many molecules of water should a student drink every week? Okay, so first thing, before I start calculating or anything, I'm just going to ask myself, okay, what is this problem looking for? And right off the bat, I see I'm looking for molecules of water per week. So that tells me that I need to find molecules of water, and I need to find that every week. And based on the context of the problem, the recommendation was 13.5 cups per day. And I already know that in 1 week, there are 7 days. And I also know that I need to go from cups to molecules. Now, based on the conversions they gave us all the way from cup to grams, but they didn't tell us any relationship between grams and molecules, which is where prior knowledge about moles, molecules, and grams comes in. So in order to solve this problem, I need to know how to go from grams to molecules. Now, from memory, I know that the molar mass of water is 18.01 grams per moles. And I know, according to Avogadro's number, I know that there are 6.022 times 10 to the 23rd molecules in 1 mole. And so these two pieces of information is what's going to allow me to go from grams to molecules. So this is kind of that piece of information or knowledge that I needed to know previously in order to solve this problem, which when you first look at this, it's not really as obvious, but when you start to dig a little deeper and understand the problem a little more, it becomes much more clear as to what pieces of information you need. Okay. So let's start with our 13.5 cups, because I am going to need to figure out how many total cups of water we have in 1 week before I start comparing cups to, start converting cups to molecules. You could do this at the end, but I feel it just feels better, or I find it easier to conceptualize or just do the problem this way by doing it first instead of multiplying it all in the end. Instead of finding molecules per day and then multiplying by 7, I find it just better to find the total amount. So I know that I have 13.5 cups per day, and I know that for every 7 days, there's 1 week. So now we're in cups, because our days have canceled out and we're in cups per week, but now we need to go from cups per week to molecules per week, and so we're in cups. And so in order to cancel out cups, I know that for every 1 cup, there are 8 ounces. And again, when you go to ounces to milliliters, I know that in 0 ounces, there are 29.574 milliliters. And I know that for every 1 milliliter, there are 0.99705 grams. Now I'm in grams, and again, if I didn't have these two pieces of information, I wouldn't be able to relate cups to molecules. So I know that the molar mass of water is 18.01 grams per 1 mole. And again, from Avogadro's number, I know that for every 1 mole, there are 6.022 times 10 to the 23rd molecules. And if I multiply that all out, I get around 7.45 times 10 to the 26 molecules. Now, for our sig figs, we also have to take into account that these are all conversions, and we're going to treat them as exact numbers and not measurements. And the only thing that we're going to take into account for sig figs is this measured value that they gave us in the problem, which is 13.5, and there's only 3 sig figs. So when we multiply all of these out, we're only going to use these 3 sig figs. So when we write our answer, we're going to report it to 3 significant figures. Of H2O per week. Now, again, the main thing with this problem was it was asking us for the total molecules of water in 1 week. They initially gave us that the recommendation was 13.5 cups per day. So I know I needed to somehow relate cups and molecules together. They gave us the conversions already to go from cups to grams, but I needed to know how to go from grams to molecules using the molar mass of water, and also how many molecules per mole there are based on Avogadro's number. And then I also had to take into account the fact that these are all exact numbers and not measurements, and so there's only 3 significant figures. But again, with these types of problems, it's really helpful to kind of really take your time to read the problem and analyze what they're asking you, and sitting down and really asking yourself, okay, I need molecules of water. How do I go from cups to molecules? Okay, we've got grams. How do I relate grams and molecules? And in class, we've done that, should have done that a lot, where you relate grams and molecules. So again, this is all just kind of building on using your context clues and prior class knowledge to kind of figure out what exactly you're looking for.